Done.
මොකද වීඩියෝ එක?
Done.
බෑග්ග්‍රවුන්ඩ් එක play වෙනවද?
Background එක play.
ඒ බලලාගෙන.
Chrome එකේ දාපු එක play වෙනවා.
ඒක මම ලියුම් කරන්නේ ඔය වීසින් දාපු ඔක්කොම නවත්තන්න. මතක තුනක් නවත්තන්න.
අපි දැන් මේ ඔක්කොම තියෙනවා.
මම මට අවුට් එකක් ඕන.
What out?
ආසවිදගෙන නැගෙන කම්හල් උලන විඳගෙන නැගින පාලම් velunu dammel niyana oba ei shaktiyai buildings that praise the heaven, bridges that rise from the earth, is watching everlasting this is our true strength. விண்ணை தொட்டும் மரமை மாற்றுங்கள் மண்ணை துளித்திடும் அழகு பாடங்கள் அன்பால் நாட்டை இணைக்கும் கரங்கள் அவையா சக்திகள் கரணி சுவிசால் பாட்டமி நகரணி விசல்யமஹ விஸ்வபுலானி ஹண்டவி மதக நிதாரணி விதையிலோவல் කම්හල් උලව විඳගෙන නැගෙන පාලම් සමගියෙන් රට වෙලුණු දම්මැල් නිහඬ ඔබ එහි ශක්තියයි from the earth, is watching everlasting this is our true strength. விண்ணை தொட்டும் மரமை மாற்றுங்கள் அன்பால் நாட்டை இணைக்கும் கரங்கள் அவையின் அசையா சக்திகள் வசரதாச கரணி சுவிசால் பாட்டெலி மதனகி விசல்யமஹ விஸ்வபுலானி ஹண்டவி மதக விதாரணி විපැයිලෝමල් ඇතෙක් නැඩුමට ඇතෙක් එන්නේ යදම් බැඳුමට යදම් එන්නේ පන පෙවුම්ලෝ මල් පිපෙන්නේ ලෝකෙටත් නෑදෙවැනි වන්නේ
විදගෙන නැගෙන කම්හල් උලව බිඳගෙන නැගෙන පාලම් සමගියෙන් රට වෙලුණු දම්වැල් නිහඬ ඔබ එහි ශක්තියයි
Buildings that grace the heavens, bridges that rise from the earth, peace watching everlasting bond. This is our true strength.
விண்ணை தொட்டும் மரமே மாற்றுங்கள் மண்ணை துளைத்திடும் அழகு பாலங்கள் அன்பால் நாட்டை இணைக்கும் கரங்கள் அவையின் அசையா சக்திகள் වසරදහසක් පැරණි සුවිසල් පතෙහි මැද නැගි විසල් යමහත් විසගුලා නිහඬ වී මදකත් විදාරණ වී පිපෙයි ලෝමල් ඇතෙක් නැඩුමට ඇතෙක් එන්නේ යදම් බැඳුමට යදම් එන්නේ පන පෙවුම්ලෝ මල් පිපෙන්නේ ලෝකෙටත්
China Lesso. Over 30 years, Lesso has taken the pipe industry as the core and laid the most solid foundation for the building of the community persistently. The total quantity of our production equipment has been more than 3,800 units, which guarantees our manufacturing capabilities. We can provide the market with a full series of products with calibers stretching from 16 millimeters to 2,400 millimeters. Our annual production capabilities of plastic tubing and pipe fittings amount to 2.16 million tons. Over 650 units of sophisticated molding production equipment. Our annual production of molds exceeds 3,500 units. By virtue of powerful scientific research strength, Lesso receives many national titles and honors, including National Recognized Enterprise Technology Center and Postdoctoral Research Workstation. So adheres to the brand philosophy of creating a relaxing life for dwellers by extending to the industry of building materials and interior decoration. Lesso is dedicated to enhancing the product quality of its sanitary ware products through fine manufacturing techniques, as well as bringing sanitary ware products with superior quality and taste to consumers. By focusing on household and lifestyle requirements of consumers, Lesso Integrated Home Furnishings provides a full range of housing services, such as integrated kitchen and wardrobes. Meanwhile, Lesso also operates a complete product line of building materials and interior decoration, including integrated doors and windows, decorative plates, integrated heating, water purifiers, and firefighting equipment. It comprehensively provides consumers with comfortable and satisfying housing services, provides integrated solutions of building materials and interior decoration. In the future, Lesso will consistently stand at the forefront of the industry, gradually develop into a world-leading large industrial group of building materials and interior decoration, and create a relaxing life for thousands of families in China and the world. China Lesso.
We are Access Engineering and are in the forefront of the construction industry with the highest number of ICTAD grading for a construction company in Sri Lanka. The company will continue to be involved in building vital infrastructure around the country, contributing to the rapid economic development spearheaded by the government. Our success story is well recognized. Today, we record the highest market capitalization in the construction and engineering sector. Whilst creating value to our stakeholders, we continue to enrich the motherland with our contribution for the well-being of generations to come.
Master Builder Solutions by BASF connects the entire global expertise and innovative strength of BASF to develop solutions for more than 30,000 clients everywhere in the world. Supporting more than 140 sites in over 50 countries, we receive and dispatch a customer order every 5 seconds on each of the 5 continents, being always close to our clients. With Master Builder Solutions, we can bring our global expertise to each local point in the world, enabling our clients to benefit from more than a century of BASF's knowledge and experience within the construction industry. We've led innovations and set standards for decades, and we will continue helping our clients to break records in construction with peak performances from the tallest buildings to the longest bridges in the world. With Master Builder Solutions, we support our clients in finding the most efficient and sustainable solution for each of their projects. But building a sustainable future needs more than just chemicals. It needs good chemistry. We believe that only as a truly connected team across various functions, professions, and countries, and in close partnership with our clients, we will achieve results. Whether it comes to technical services, long-term support, or yet unprecedented challenges, Master Builder Solutions from BASF is the world's most experienced and best connected partner for expert users of construction chemical solutions. Master Builder Solutions from BASF. We create chemistry.
Ladies and gentlemen, the next half of the event proceedings will be started at 11:10 a.m. Please be seated in the department seminar room by then. Ladies and gentlemen, the next half of the event proceedings will be started at 11:10 a.m. Please be seated in the department seminar room by then.
Ladies and gentlemen, I hope you have settled in after the department tour. For now, we begin the second half of the symposium. Prior to that, let's take a look at a video presentation prepared to introduce our gold sponsors, Melvire Rolling Private Limited, which it would be impossible to organize this event without their extreme generosity and support.
විදගෙන නැගෙන කම්හල් උලව බිඳගෙන නැගෙන පාලම් සමගියෙන් රට වෙලුණු දම්මැල් නිහඬ ඔබ එහි ශක්තියයි
Buildings that grace the heavens, bridges that rise from the earth, He's watching everlasting goals. This is our true strength.
අසයා ශක්තිகள் වසරදහසක් පැරණි සුවිසක් රටෙහි මැද නැගි විසල් යමහත් විසඹුලා නිහඬ වී මදකත් විදාරණ වී පිපෙයි ලෝමල් ඇතෙක් නැඩුමට ඇතෙක් එන්නේ යදම් බැඳුමට යදම් එන්නේ පෙවුම්ලෝ මල් පිපෙන්නේ ලෝකෙටත් නෑදවැනි වන්නේ
in the morning today, which is given by students. First presentation, I will make the title and the name, is given by Mr. Erandin Jayasuriya. The topic is given as the effect of penetration of corrosion on the load-bearing capacity of steel. Please welcome Mr. Erandin Jayasuriya.
Right. Thank you, sir. Good morning, ladies and gentlemen. Mesdames et messieurs. Welcome to MESII 2019. I'm E.D. Jayasuriya. My supervisor for this project was Professor Nanda Munasinghe, who sadly could not be here with us today. He has commitments elsewhere. And the title of my project is The Effect of Penetration of Corrosion on the Load-Bearing Capacity of Mild Steel. If I stay here, can you see the screen? Yeah, no problem. Right. Right. This shall be the overview of my presentation. There'll be an introduction. It'll be quite long. And I've cut off quite a few slides from this presentation so as not to make it too technical. But I hope you keep up. I'll speak a bit fast and go through the slides a bit quickly in order to finish it in the 10 minutes allotted to me. There is related research and scope for differentiation, the methodology, the observations, results, and trends, and the conclusions, limitations, and recommendations. What is a corrosion map? I'll do away with this mic. Right. What is a corrosion map? A corrosion map is a geographical distribution of corrosivity data that tells you, depending on where you want to build a structure, for example, in Sri Lanka, it tells you what steel or other metal or class of alloys to choose, how long it may last in those conditions, how often you have to run maintenance checks, and obviously when you should replace it outright. These are some corrosion maps of the southern tip of Africa, and I think this is Northern America. And you can see that along the coastlines, the corrosion is most severe. That should be intuitive. Now you see the UK again along the western and eastern coasts. You see Australia and New Zealand, so the Great Barrier Reef area and the southern tip of the South Island in New Zealand. So this is intuitive, and as you head inland in some of these countries, there's no corrosion whatsoever. And this is our lovely neighbor, India. Corrosion is most severe by the sea, and quite a bit of corrosion even as you travel inland. I'm assuming it has something to do with the Indian Ocean. And an interesting anecdote about this section, I think that is different from this lighter green because the gaps run along these two sections. Not that it's relevant to this presentation. This is the attempts made to create a corrosion map of Sri Lanka. Why does Sri Lanka need a corrosion map? It should be quite obvious. We are quite a highly corrosive sort of country, and because we are such a small island, the corrosivity does not cease as you go inland for quite a distance. So there have been two types of attempts made to make a corrosion map of Sri Lanka. The first one I discovered in the making of this presentation a few days ago was by a gentleman in the Department of Mechanical Engineering, University of Moratuwa, in the year 2004. He attempted to amalgamate 5 indices: salinity, humidity, rainfall. Industrialization is the amount of sulfur dioxide in the atmosphere, and he made a sort of index by district, which is very useful. I do not know if it was published, but I found it nevertheless. The second attempt is by a research student of Professor Munasinghe himself at the Open University, one Mr. Adhikari, maybe he's here, I do not know. He attempted to make an equation with 5 or 6 elements, which is far more accurate, given the time of year. Assume you are sort of running your factory in a certain time of year and then closing it for a few weeks and so on. This is very accurate in that you can take a highly local rainfall, a highly local salinity, and sort of tailor the metal or alloy you need to your exact requirements and the environmental conditions existent at your location. How does this relate to my project, or how does my project relate to the bigger picture? Obviously, once one has made a corrosion map, selected the steel, made the building, and then gone to work at the building, one realizes that almost any metal corrodes, and there's only so much that galvanizes. So after a time, one must run what is called a residual strength analysis. One takes a portion of the load-bearing member, sends it to a laboratory, and then the laboratory says, in 6 months, you'll have to replace this component. How a person does that is they extrapolate the sort of section that actually bears the load, and this is now done ultrasonically. But we wanted to see, in the interest of science, and because I needed a final year project, how much the effect is that the section you do not see that is corroded to your naked eye, even after washing with acid, how much of an effect that has on the load bearing section. So the hypothesis is that there is a certain micropenetration depth beyond the general corrosion layer. This is much more clearer in my next slide. So essentially, that is the layer you see to your naked eye. And then once you wash it away with acid or scrape it off, you get what is assumed to be a load-bearing section. However, we wanted to see how much that little part with the incisions I have put like tiny worms, we wanted to see how much of an effect that section has on the load-bearing capacity. We hypothesized that is actually this smaller inner section that bears the load, and that this does not bear a load at all, or that it bears a very little load. And the research in this area is quite extensive and enthusiastic, because some of these research projects are 26 years old. It's amazing. And they have been done in Eastern Asia, in the Middle East, in Greece, Central America. And all of these researchers have mentioned this sort of problem that I was going to investigate, but they have not gone into the nitty-gritties because they realize that the problem could be overcome with a safety factor. Any of you in structural engineering will know this. But they had mentioned that this corrosion measurement may not be able to reflect the influence of local corrosion hits. Go back 2 slides if you can, please. Yeah, there. So essentially, they have mentioned that this has an effect, but that they could not determine what said effect was. 3 slides. 1. Thank you. So the methodology of my project, I shall not run through all these sections because it's boring and it'll take a lot of time. But quite an extensive methodology. I had to do quite a lot of research. And the real important bit is the correlation of results at the end. So, right. And this should be an intuitive sort of table for you, because the breaking loads ought to go down as time passes and it corrodes. That should be obvious. And so does the extension at fracture, and as is this relation. But I'll come to these graphs a bit further on in a sort of amalgamation of 2 or 3 graphs together. And this is the mass loss analysis. Again, intuitive. Obviously, you should lose more and more mass as time passes. That means less and less mass is retained. And this is the mass loss curve. Again, a downward trend. Switch, please. I'll spend a bit of time on this slide. Now I have included the hypothetical initial steel section. You will wonder why the rust goes up and down. Obviously, rust is less dense than steel, but we are not interested in the bit that goes up. We are interested in the bit that goes in. That is the so-called general attack, and this is what I call the penetration of corrosion. So we wanted to see, in relation to that X value, how significant the Y value is. And to do this and to correlate this to my project title, we needed to have an idea of the expected versus actual load retained. And the expected load retained is essentially the mass retained, right? That should be obvious, because it is assumed to corrode equally from all sides. And therefore, once the mass is lost, the load is lost, the cross-section is lost. Whereas these are my actual readings, and you can see, especially in the first month and the second month, that correlation the researchers in the thesis said, it exists, it's very similar. But once you get to the last month, there is a loss of 18% here and a loss of 34% here. That is nearly twice. That is significant, and I'm not entirely sure a safety factor can cope with that. And this is the sort of relation we saw. So going by the enlightened research of the world, this green curve should hug this blue curve. It should be perhaps 105% correction, 110% correction, whereas this deviates quite significantly as it goes further down. And to study the sort of incisions I mentioned, we had to conduct scanning electron microscopy in our lovely SEM. And this is the macro shot. You see the polymer layer on which my sample is mounted. This is the bit of general corrosion, and this is the steel. And this is the sort of layer of incisions. And we zoom this in to a 500, and you get this. This is one so-called incision. And that incision is subjected to what is called EDS elemental mapping. I think it's energy dispersive spectrometry. And we choose the elements iron and oxygen alone, and this is the oxygen alone. But obviously this could be anything. This oxygen need not necessarily be Fe2O3 or any rust phase. So we had to subject this to what is known as an X-ray diffraction analysis as well to find out the phases in this rust, and they correlated. And this is sort of the measurement of my microscopic analysis. These are the actual depths I got. The theoretical depths can be reverse calculated from the graphs shown earlier where there was a disparity. So the disparity is alluded to a certain depth that goes in from all four sides. This is pretty similar. We were amazed. This showed quite a correlation. I think the third month is rather anomalous, but that is to be expected because the corrosion pits are local and this is not a foolproof method. And this is the sort of comparison of the two curves. You can see that it is due to this data point that the graph sort of deviates massively. It would have gone much closer to the green curve otherwise. And this is my final, the sort of crux of my research. I assume that I have proven that the penetration of corrosion is directly proportional to the load ratio. And what you can understand from this is that if we were to go by the research hypotheses of the world, this sort of ratio ought to have existed between 100 and 95, somewhere here. Because as soon as the incision goes in, the general layer ought to follow. That should be the natural assumption. But we found out that it wasn't. It deviated quite significantly the further the penetration of corrosion went in. And this penetration kept increasing as well without the general layer following. So that was quite an amazing feat. I have removed the data points because that third anomaly comes somewhere here and makes the graph rather ungainly. But yeah, what? These are the conclusions I reached. Obviously, the expected versus actual loads are different. That was a real eye-opener. But more importantly, we could successfully prove our hypothesis that this disparity in the two loads was relevant to the penetration of corrosion. There might be other factors as well, but we started out with this factor and it showed quite a nice proportionality. And there are quite a few limitations to this project, as the academic staff pointed out to me throughout the progress reviews. The most obvious ought to be that it was done in a corrosion chamber in a really high salt atmosphere. It had to be the case because I only had a year to do this project. But in a general corrosion situation, what you might find in your house or in your office building, this might be quite different. Perhaps general corrosion progresses quite slowly and without the incision going deeper after all. And the measurement was done in a rather linear sense, whereas the actual penetrations can take a curve, a hook, and any number of shapes. So if someone were to optimize that, I'm sure they'd get a much closer result in that curve that showed the deviation. And the last one, obviously, is we recommend that someone make a phase-wise study of this, where they superimpose the ferrite versus the pearlite and see if that has a difference, because ferrite is more conducive to corrosion, that is well known. And there is a recommendation that is not mentioned here, which was followed by my juniors, and they developed this project to a much higher degree, but I'll answer that in the questions and answers if you're interested. Thank you very much.
Okay, thank you, Randin, for presenting a nice presentation. Now this is open for discussion. I can give you 5 to 6 minutes for discussion and questions and answers. Yeah, it's open.
Yeah. Okay. So I'll take a minute to expound on the point I made earlier. It's the fact that my juniors have a much more robust project. They have actually tested the steel. I just did like a pretty simple tensile test of the corroded specimen. They have fatigue loaded the specimen, and then they have done a much more intensive project, and they've modeled it using FEM analysis. And it's a shame that they couldn't present this at this symposium, but I'm sure if you were to attend the next one, you'll see a much more well thought out and better evolved iteration of this project. So well done them.
Thank you. I have a little question.
Yes,
so when you do CMN index analysis,
yes, sir.
So the sample is a metal piece you put into the chamber. Okay.
So, but it's the metal. I'll just use it. the metal piece has to have that sort of general corrosion layer on either side for us to superimpose the EDS reading. So the real challenge is in setting the polymer so that the rust isn't flaked off.
So actually you focus between the metal and the rust place?
Yes.
Yeah,
Definitely.
in the area.
Yeah,
Okay.
That's right.
Okay, any more question? Okay, thank you very much. If there's no question, we'll actually thank the speaker and move to the next presentation. It is done by Miss Harini Munasinghe. The topic is extraction and the use of natural dyes for fabrics. Yeah, Miss Harini Munasinghe. Yeah.
Good morning, everybody. I'm Harin Munasinghe and my project partner is Damit Veerasinghe and our supervisor is Mr. S.V. Uday Kumara. Before going directly into the project, let me take you through the background. During my internship period, I got a chance to contribute on a project which is regarding to removal of synthetic dyes disposed to waterways. After the end of the project, when we published the project, most of the textile companies wanted to buy that project, and most of the textile companies were interested about that idea. At that moment, I began to think why all these textile companies spend huge money to make it minimize the harm and the toxic of the waste dye they dispose to environment. Instead of why couldn't they invest on a solution which release less toxic and less harmful dyes to environment. That's what made me choose this project, extraction and use of natural dyes for fabrics. First of all, let me give you a brief introduction about toxic dyes. Today, most of textile companies use synthetic dyes for their dyeing process. So these synthetic dyes made using toxic chemicals. These toxic chemicals from synthetic dyes create a severe environmental disasters in the form of air, water and soil pollution. These two pictures shows you how today most of the textile companies dispose their waste dye directly to the environment like soil and waterways. And also because of these things, today textile processing industry become one of the major environmental polluters in the world. And also this picture shows you how these synthetic dyes can be harmful to human body and human skin. Because of all these causes, today most of the companies started to use natural dyes instead of synthetic dyes. So usually natural dyes are derived from natural sources like plants, animals and minerals. And also they are mostly non-substantive and must be applied on the textile by the help of mordant. So what is a mordant? Usually we call mordant as a chemical compound which increase the dyeing ability of the fabric. And also we can say that this mordant acts as a bridge which connect the dye molecules and the fibers and increase the dyeing ability of the fabric. After the dyeing process, we can measure the color intensity values of the dyed fabric piece to get an idea but the color hues and the color strength of the dyed fabric piece or the dye. Then also we can measure the fastness properties of the dyed fabric piece to evaluate qualitatively to measure how these dyed fabric piece can withstand for washing, rubbing, perspiration and plant. In this project, we choose Acalypha hispidea, which is generally known as monkey tail flower, to extract the dye. And also we chose this flower because it's freely available and have rapid growth and gives bright colors. After finding the best natural source to extract the dye, then we done the dye extraction process. The dye extraction process was done under simple aqueous extraction method. Here we cut these flower into small pieces and the dye extraction was carried out using the water as the solvent at 100 Celsius for 2 hours, and the solution was filtered and we get the dye extraction solution for the further dyeing process. And after the dyeing process, dye extraction process, before go to the dyeing and the mordanting process, we treated the fabric piece with 4% tannic acid solution for 2 hours at room temperature. By treating the fabric piece using tannic acid, it increases the surface activation of the fabric piece and also it increases the dyeing ability of the fabric. After done the fabric treatment and the dye extraction, we go to the dyeing and moldenting process. Before I explain you what is a mordant, so here I am going to tell you what are the mordants we use in this process. We use aluminium sulfate, which is known as alum, ferrous sulfate, potassium dichromate, copper sulfate and stannous chloride. In here I need to mention that if these chemical mordants, the concentration of these chemical mordants are below 2%, it's not toxic and harmful. So because of that, in this dyeing process, the concentration of these metallic salts we use is below 2%. Because of that, it's not affect the toxic of the natural dye. And also after that, we did the moldenting process under 3 different moldenting methods. The first one is pre-moldenting method. Here we first did the moldenting process using tannic acid treated fabric piece. Then we did the dyeing process for the moldented fabric piece and obtained the dyed fabric piece. The second method is simultaneous moldenting method. In here, instead of dyeing and moldenting process separately, here we did the dyeing and the moldenting process at the same time for the tannic acid treated fabric piece and obtained the dyed fabric piece. The third method is post-moldenting method. Here first we did the dyeing process, then we did the moldenting process for the dyed fabric piece and obtained the moldented at the dyed fabric piece. After the dyeing and the moldenting process, we need to test the fastness properties of the dyed fabric piece. For that, we test the fastness properties of the dyed fabric piece using ISO standard method for washing fastness test, rubbing fastness test, perspiration fastness test and light fastness test. After testing the fastness properties of the dyed fabric piece, then we tested the color strength and the color hues values of the dyed fabric piece using data color spectrophotometer. The specific color of the dyed fabric can be found based on the LAB color coordinate value. This LAB color coordinate value is similar to XY coordinate. Using this plate and this sphere, we can get the specific color for that dye using this LAB color coordinate value. After that, we optimize the moldenting method for the monkey tail extracted flower dye. So using it means we find out which moldenting method gives the best color strength value for the cotton fabric piece. So from this graph you can see that these red bars gives high color strength values than the other two colors. So that's the pre-moldenting method. So we can say that the pre-moldenting method gives high color strength values for most of the mordants except for the copper sulfate. So because of that, we can continue the moldenting and the dyeing process for the pre-moldenting method. And this is the color strength value which can obtain from each dye, each mordant, and from this graph we can say that which mordant gives the highest color strength value for pre-moldenting method using monkey tail flower extracted dye. And here you can see that the chrome and the ferrous sulfate mordants use high color strength values, and also alum means aluminium sulfate give less color strength values. And also here's the color produced on the cotton fabric piece using these mordants, and these are the colors we obtain from the monkey tail extracted dye. So after that we need to we need to evaluate the fastness property results we got from the fastness properties test. So the dyed sample exhibited excellent and wash perspiration fastness properties, and also the rub fastness of the cotton samples was better for both dry and wet rubbing, and also the cotton samples exhibited good dye fastness properties under all application conditions. And also here's the color palette we obtained from the dye. Here the color palette we obtained from the monkey tail extracted dye. Here bottom, this is the standard color palette which we can obtain from synthetic dyes. And here above that you have the color palette which we obtained from the monkey tail flower dye. When we compare these two color palette, we can see that the colors which given by the synthetic dyes also can be get from the monkey tail flower dye as well. So it means we can replace natural dyes instead of synthetic dyes for any color we want. And also we were able to publish our project in the International Forestry Environment Symposium held by University of Sri Jayewardenepura. The publication name is Extraction of Natural Dye for Acalypha hispidea for Fabrics. And when it comes to the conclusion of our project, we can say that the ACOS extraction method is the best extraction method for monkey tail flower. And also with the pre-molding method, it's more efficient to dye the cotton fabrics. And tannic acid increase the dyeing ability of the cotton fabric piece. So these are some differences which we took some ideas for our project. And thank you very much for your attention.
Okay, thank you for the presentation, Harini. Now it's open for discussion and questions and answers. Any questions? Harini, what is the light effect of these dyes?
Sorry?
Light effect of these things? Do you expose into the light and see whether it's degrade with the time?
Yes. Oh, you want the values or the?
Not values. How it looks like? I mean, that are they stable in light?
Yes, yes. We did it for 8 hours, 2 days and 8 days. After 8 days, also the color is not fade away.
Fade away.
It means direct sunlight and the direct UV light.
Natural light, normally when you coat with some other material, actually exposed to light, they decay quickly.
Yes.
Yeah, that is a problem. I think with the cellulose, it makes some complex material with this inside. Yeah.
Yes, because of the metallic salt we used as mordant, I think that's because of the light doesn't fade from the color dye.
Okay.
Thank you very much.
Professor Adhikar also has a question.
So the ml ratio we use for the dye extraction is 1 to 10. It means the natural 1 gram of natural source and 10 milliliter of water. It means it's less than the. It's not more effective than the synthetic dyes at the beginning. But if it start to do it like regularly, it can be more effective and more cheap than the synthetic dyes. No.
Okay. Is there any more question? If there's no any question, we will thank the speaker and we will finish the presentation and move to the next one. Next presentation is given by Mr. Tarak De Silva and on development of vibration and shock sensor using piezoelectric ceramic. Mr. Tarak De Silva. Yeah.
Thank you for your being here today. My project topic is development of shock and vibration sensor using piezoelectric ceramic. I am Mahesh. My project partner is Anupa Dayananda. Project was supervised by Professor S.U. Adhikari. First of all, I am going to explain how to show my project. First, I will tell you introduction of my project, then methodology and result and discussion. Okay, let me move on to the introduction. First, we understand what is shock and vibration sensor, and then what is piezoelectric ceramic. Shock and vibration sensors are used to determine the shock or vibration on a structural building. Using the result of sensor, we can say what is the amplitude and what is the acceleration and what is the RPM of vibration, like that factors. Then what is the piezoelectric ceramics? Piezoelectric ceramics are smart material. Smart materials means that can be response to environmental stimuli, and it can give the response. According to the piezoelectric material, stimuli is the stress and the response is the electric field. Then how to detect the vibration and shock using the piezoelectric ceramics. Conversion of mechanical energy to electrical energy generates an electrical signal which can be used to analyze the behavior of vibration. As you know, vibration has a mechanical energy, so we can detect that mechanical energy. We should have a object for design sensor. Therefore, we use this design objectives, measure the real-time vibration or shock on a structural building in cosmetic damage range, compute the amplitude and frequency of vibration in cosmetic damage rate, give a warning if vibration level exceeds the cosmetic damage rate. If I say what is the cosmetic damage, that are the smallest damage can be happen to the building as a result of cosmetic damage. Hairlines crack can be propagate on a structure without knowing people. If exceeds that level, it's going to enter the minor damage. That was very critical. This is my design apparatus. We use the cantilever beam with piezoelectric ceramic for vibration detect and signal generator. Then Arduino board used to collect the data coming from piezoelectric ceramic. Then use the liquid crystal display and buzzer for indicate the data. This is my methodology. Cantilever can be designed which is vibrate according to the vibration frequency. When the beam vibrates, stress are automatically increase and decrease through the beam. In here you can see sorry. In here you can see how to respond the beam into vibration. This is my piezoelectric material. According to the vibration, it creates the electric field. There are a lot of equations behind my project. I have mentioned two equations only. First equation can be expressed to determine the natural frequency of beam. Then this equation can be expressed to this equation can be expressed to electric field generates in a piezoelectric ceramic. There are a lot of constants. They are all can be taken from the property table of piezoelectric ceramics. First we have done the software mathematical modeling, but we want to improve the accuracy of result. So we have done the software simulation. Therefore we use the therefore we use the console mastery software. The sensor model is divided into large number of small parts and solve it through the iterations. Then we take the most appropriate result for the sensor. This figure shows you how to show the finite element analysis view of sensor. Then this figure shows you how to variate the total displacement of sensor along the cantilever beam. You can see this end has a higher displacement. This place is in constant. This figure shows you stress distribution of sensor. We want to check the stress distribution because it can be undergo the yielding. We can't use it as it is. This is the most important part of my project because we measure the electric field in a piezoelectric ceramic in a z-axis. This figure shows you how to variate the electric field in the piezoelectric ceramic. These are the dimensions. Finally, I was found from the software. Then, according to these dimensions, I was made the prototype model. These are the simple equations we used for my project. From the software we take the polarization density, and according to the polarization density we take the voltage along the piezoelectric ceramic in the cosmetic damage range. This is my prototype model. In here you can see piezoelectric ceramic in here, and this is the cantilever beam. This is the liquid crystal display. This is the Arduino board, and this is the battery. You can use it as a prototype model for measure the vibration frequency in structural building. This motor was used to make a vibration stage. When the sensor is subjected to Arduino board, it gives a signal like that. There is no relation with the frequency. It was disappeared. So we have done the Fourier transformation. During the Fourier transformation, time domain signal convert into electrical frequency domain signal. Then we can say what is the frequency of signal and amplitude of signal. This graph shows you how to show the faster Fourier transformation of signal. In here I was cut off that range and that range because they are not in the cosmetic damage range. This is the most dominant frequency according to my application. According to that graph I take the frequency and amplitude. Then if we know the frequency and amplitude, we can say what is the velocity, acceleration and peak particle value of vibration. Peak particle value means velocity related to the maximum amplitude of sensor. This is my conclusion. This sensor model could indicate harmful vibration on structural building. Comparatively high accuracy, 92.92% of approximation voltage value was obtained from the device. Compared to the software simulation, accuracy can be further improved by using further calibration and testing. Thank you.
Thank you. Thank you for the presentation. Now it is open for discussion and the question. Yeah, one question.
Piezoelectric material, copper and mild steel support. No, piezoelectric material we can import in from USA, and copper beam used to as a substrate for the piezoelectric material, which was done from here. Sorry. Yeah, this is done as a design project. Actually, we have depend on the 4 Hertz to 16 Hertz range, because we are not going to, not going to that case. Thank you.
Okay, thank you. So, yeah, the question, please. Yeah, you can ask. Yeah. Targa, is there a threshold value for this vibration?
Yeah, we
what is
use
the
14. We had safety factor 1.4, and it takes to 10. Then we design it, but according to the design trouble, we select as a 9.65.
But the cosmetic damage threshold value is how much?
It is 4 Hertz to 14 Hertz.
So
if it exceeds that level, we give a LR as a warning.
Okay, is there any question? Any more questions? If not actually we thank the speaker again. And that concludes. Thank you, Darga. So that concludes the presentation. 3 presentations were there. And actually very good presentations, all presenters presented, and the work and also the things that presented, there is in very good quality and high standard research. And I thank you all the presenters and the participants who participated for this. So thank you very much for that.
Thank you, sir, and my dear colleagues. The next video presentation will introduce you to Sand Trading, our silver sponsor for the day.
China Lesso. China Lesso. Over 30 years, Lesso has taken the pipe industry as the core and laid the most solid foundation for the building of the community persistently. The total quantity of our production equipment has been more than 3,800 units, which guarantees our manufacturing capabilities. We can provide the market with a full series of products with calibers stretching from 16 millimeters to 2,400 millimeters. Our annual production capabilities of plastic tubing and pipe fittings amount to 2.16 million tons. Over 650 units of sophisticated molding production equipment. Our annual production of molds exceeds 3,500 units. By virtue of powerful scientific research strength, Lesso receives many national titles and honors, including National Recognized Enterprise Technology Center and Postdoctoral Research Workstation. So adheres to the brand philosophy of creating a relaxing life for dwellers by extending to the industry of building materials and interior decoration. Lesso is dedicated to enhancing the product quality of its sanitary ware products through fine manufacturing techniques, as well as bringing sanitary ware products with superior quality and taste to consumers. By focusing on household and lifestyle requirements of consumers, Lesso Integrated Home Furnishings provides a full range of housing services, such as integrated kitchen and wardrobes. Meanwhile, Lesso also operates a complete product line of building materials and interior decoration, including integrated doors and windows, decorative plates, integrated heating, water purifiers, and firefighting equipment. It comprehensively provides consumers with comfortable and satisfying housing services, provides integrated solutions of building materials and interior decoration. In the future, Lesso will consistently stand at the forefront of the industry, gradually develop into a world-leading large industrial group of building materials and interior decoration, and create a relaxing life for thousands of families in China and the world. China Lesso.
This brings to an end of the first undergraduate presentation session, establishing a platform for new ties with the leading lights of materials engineering industry so that in turn the graduates from our department may transit seamlessly into their chosen vocations. Department Industry Consultative Board has played an important role in our department history. Furthermore, this is a golden opportunity to discuss the potential research collaborations with our department and to seek clarifications regarding the consultancy and testing services we can offer to the industry. Prior to this session, I cordially invite the head of the Department of Material Science and Engineering, Mr. Sampath Veragoda, to brief the objectives of this session.
Good afternoon, ladies and gentlemen. As was introduced, this is another important session of today's program. Here, the main objective of the department industry consultative session is to get us a feedback on our graduates and to build an opportunity for meaningful industrial interaction. I will be brief in this introduction, and so basically these are the objectives of the Department Industry Consultative Board. And before we can ask from you about the feedback of our program, I intend to give you a brief idea about who we are and what we do, and about our study programs, and so on. So this is a brief introduction to the department. We have been around since the 1970s, and of course we are actually the only academic entity that produces materials science and engineering graduates in Sri Lanka. Right. And so far, we have produced about 800 graduates from our department. And if we look at the department at a glance, we have about 200 graduates at a given time. And right now, we have about 60 postgraduate students, including those who are following the master's programs and the research students. And altogether, we have about 31 permanent staff members, both academic and non-academic. And as for the infrastructure, currently we have 10 laboratories and 3 lecture rooms. So we are relatively a small department compared to the other departments in the university, and our annual intake of students is 50. Here we have I have given you a brief indication about the different expertise in our academic staff, and as you can see, we have a very wide coverage when it comes to the field of material science and engineering. We have basically expertise in all aspects of materials science and engineering in our department. And I will also show you some of our laboratory facilities. So these are 3 of our laboratories, and our metallurgical lab is perhaps has been around for a long time, but we have modernized it to suit the modern requirements, and perhaps we have one of the best capable metallurgical laboratories in Sri Lanka today, and so is the polymer and the materials testing laboratory. Our equipment are all up to date and are in prime working condition. So, and these are some of the other facilities in our laboratories. We have the materials processing laboratory, the heat treatment laboratory, and the foundry laboratory. So why I am emphasizing on the laboratories and equipment is mainly unlike in most other fields of engineering, we cannot do anything with materials engineering unless we have good equipment and lab facilities. So we have always strive to keep our laboratories up to date and well equipped. Right. So here we have the analytical laboratory. We have some of our latest acquisitions there, and state-of-the-art scanning electron microscopes and X-ray analyzer. And recently we have acquired another spectrometer. This is one of our ceramics processing laboratories. And these are actually our latest additions to the equipment facilities. So all these equipment facilities are available for those anyone who is interested, and we will be happy to provide our services in materials analysis and testing. If we briefly look at our undergraduate program, these are the main subjects that we deliver to the students. Includes fundamentals of engineering and fundamentals of material science and engineering, and then we have applied material science and engineering, which includes the areas as given. So these are basically the material science and engineering knowledge that we impart on the students, and in addition we have some subjects on industrial management and marketing, and also we have a period of training for the students which spans 6 months. So the structure of our degree program is as given in the slide. It is based on material science and engineering, mathematics, and engineering design, IT, and the management subjects, which is core to the general engineering program as well, plus the materials science and engineering knowledge. So a graduate who is passing out as a materials science and engineering engineer has a core knowledge of engineering in him or her, plus the knowledge on materials science. And our course is streamlined on 4 channels. We have the polymer engineering subjects, and we have electronics materials engineering subjects. Then there are metallurgical engineering subjects which related to metals, and also we have ceramics engineering subjects. And at the end of the course, the students get a degree in materials science and engineering, and they have the option of either having a focus area on polymer engineering or focus area on electronics materials engineering when they graduate. So just to highlight what a materials engineering graduate consists of, it is basically as given in this picture. These are the inputs that we give to our graduates. So they start with the chemistry, physics, and mathematics knowledge from the advanced levels, and we give them further knowledge on those subjects as well, plus the materials engineering subjects and the general engineering knowledge. So these are our inputs to the graduates who are passing out from this department. And once they pass out, this is the area in which we expect this is the area in which we expect our graduates to perform. So it can be a manufacturing or a construction industry, and so the other areas are so the materials engineer can function by coordinating the manufacturing, quality assurance, uh, failure analysis if applicable, and also he has a knowledge on engineering design and research and development. So we expect our graduates to function amidst these areas inside a industrial organization. So normally, of course, up to now, we don't have a particular designation called the materials engineer in most of the industries, except for a few establishments. However, this is the general area in an establishment that we expect our graduates to perform. Um, However, the focus will be more on research and development and quality assurance on when it comes to the knowledge of the engineering graduates. And this is the are some statistics of our graduates at the last taken at the last convocation, but unfortunately we couldn't get a 100% picture on the graduates because most of them did not contribute to the statistics. So this is result of about 35 graduates out of the 50. So this picture is not totally not totally different from most of the other fields of engineering in University of Moratuwa, and so the figures are almost the same for chemical engineering, mechanical engineering, material science and engineering, and even electrical engineering. However, we generally for the past 5 years, these are the areas in which our graduates have been employed in. And last year also it was not significantly different. A lot of them have gone into the construction industry of recent, and almost an equal amount has gone into the manufacturing sector as well. So I will brief you about our postgraduate programs as well. We have a postgraduate degree program in material science, which is a taught program, and we are actually planning to introduce the master's program in nanotechnology this year. We have already got the approval from the UGC, and also we have master's degrees and PhD degrees which can be carried out by research in the department. So that was actually a basic idea about what we do as a department and how our study program is constituted, and about the some statistics about graduates as well. So in the I have given you this information as a kind of a prologue to the next discussion session which we'll be having, and uh, with that, I will conclude this small introductory presentation, and we will move on to the discussion session from now.
Thank you, sir. The next discussion session will follow 5 themes and will be steered by a panel comprising the current and former heads of the department. I now invite the chair of the ICB session, Professor Upali Adhikari, along with Mr. Sampath Veragoda and Dr. Kalyani Liyanage to assume their seats at the head table.
Good afternoon to all of you. Now we are in the consultative session of the Department Industry Consultative Board meeting. So the main objective of the consultative session is to get the feedback from the industrial representatives, our alumni and our students about their degree program. So we have prepared flow slides basically focusing on 4 sectors like the first is the department industry interaction. Yeah. So under that, of course, you know, we have 4 areas to discuss: the current status, the consultancy services, testing services, and future awareness. So under the current status, we would like your contribution about the industrial training of our undergraduates and the industrial visits that we do. So here, of course, we have the representative from the industrial division of the Faculty of Engineering, Engineer Ananda, and of course, he the director of the division. Maybe he can initiate the discussion so that we can move on hereafter.
Thank you. Sir, good afternoon. Yeah, acting director at the moment, training division, and my colleague Engineer Tissadarangud also with us. And from the department point of view, Dr. Dinesh Artigal is coordinating from the department. And first of all, I'd like to thank almost 55 organizations and the senior engineers and the mentors who helped us and molding our students during the industrial training division. And if I say the industrial training, that is not only the technical thing, and that's the time our students and our children are exposed to the society. Therefore, your guidance and mentoring is very much important from the beginning. Therefore, I kindly request you at least having a 2-3 days of orientation from your respective organizations to our students. Sometimes not only the students from the material sciences, some civil engineer students and the mechanical engineering students also coming to your organizations. If you can organize kind of orientation program for them, I think that is then the industrial training module may be more successful. From our point of view, and we are having an orientation program for our students, and we like to invite some of your representatives to the come that session. Probably Dr. Dinesh Artigal and Engineer Tissadarangud and myself, we can coordinate with you for the especially the orientation program prior to the industrial training. Other one is during the industrial training,
we are having so much of visits from the industrial training division as well as the department. With that, that's also maybe kind of a good session to improve how to improve the industrial training. The other one is that not lastly, during the industrial training final assessment, and if your representatives be present for the final assessment, not only assess the student, that's a forum which we can improve the industrial training module for the next batches. With that, actually, myself and will start the forum. This probably you can add something.
Right. The most important thing we all should keep in mind, though it's a bit controversial opinion, we are sending a student to get trained, to get mentored. සිංහල කිව්වොත් දඹුලේ ගිහලා තලගොයිත් මරාගෙන ඉන්න පුළුවන්. I mean, you can get some job done, but the main purpose is to train, mentor him. So the dialogue which Mr. Engineer Anand Gamage highlighted is to enhance that process of mentoring or training. So to start with, we should know in which aspects the student should get trained or be mentored. We are sending students of all sorts of psychologies and all sorts of physical behaviors, or physical attitudes, I should say. So you all who are very senior members and senior engineers, senior professionals, know that they are coming from all sorts of different backgrounds. So how shall we bring them to a common, how should we bring them to a common platform and develop their skills and support them? You should train, or we should support you to train through a structured training program in all aspects of the organization, financials, logistics, safety, environment and health, everything. Maybe even housekeeping. So we should get together and develop this particular thing. If you already have, if you're multinational, if you have support from your principals, fantastic. Share that knowledge with us so we can come up with a better program. You may share your thoughts.
Yes, we like to invite the industrial representatives for your views, especially regarding our students. Of course, you know, most of your companies accommodate our students for their industrial training. So we need to improve the students' qualities, their capabilities, and their training experience, etc. So please comment your experience about our students and how to improve the qualities of our students through the training period. If there are any drawbacks, of course, you are welcome to highlight those drawbacks also. Okay, please comment on this. Mr. Jaisingh from Mella, can you? Yes. You guys.
I'm Gamini Hapuarachi. Hi, sir. From petroleum industry. I'm 40 years worked in material corrosion, NDT, all these things. I happened to meet one of your students while I was in Saudi Arabia. So you just asked about the attitudes. I found actually I met him, hired as one level. I managed to put him to a higher and higher level. So he entered as some level, came out of the refinery at a very high level as an engineer equivalent level. He showed the diversity, enthusiasm to keenness to improve in the area, expand his knowledge. I really appreciate that. I don't want to name his, Mr. Veeragoda might be knowing, the person who recommended me. Just I want to add a little thing here. Mentorship. As Tissa pointed out, this is one of the very lacking thing with among our most of our seniors. They are not giving the right mentorship. They're asking them to, you find it out. No, it's not the way. You have to give them challenges, appreciate them, work with them, and then work for the benefit of the future. So this is really something missing from our part, majority. And the second thing, I just wanted to add that something to this Mr. Veragoda's briefing about the industry. What is the role of the material engineer today? The material engineer's role actually should start from the conceptual design and to the detailed design, because materials are being used in the industry, particularly in my knowledge in the petrochemical industry, for the petroleum and chemical plants. And I saw you are more emphasizing on the destructive testing. Now the days are gone for the destructive testing. Everybody now more interested in the non-destructive testing. Because the plant maintenance and asset integrity management plans have been vastly different, approaches are different. They are all going on risk-based management, risk-based users. So material selection and the right specific material specifications, all these things are becoming very, very important, particularly towards the degradation mechanism expected out of those things. So material engineers have a better role in the industry, from the conceptual design to the detailed design to the plant maintenance inspection and continued monitoring of the RBI output. So there's a big scope for them. So I just wanted to emphasize on the importance of the mentorship, and the quality of the people I have seen from you so far are excellent. Thank you very much.
Thank you. Thank you very much for your comments. Your comments are well taken, and we are very encouraged by your comments about the quality of our graduates. So we need more comments from the industry actually. Those who, first item is the industrial training. Those who provide industrial training, of course, you are welcome to give your comments. Maybe from the Melvai.
Thank you all of your arrangement, because we have enabled that this kind of forum to the interface with your existing system. We are also one of the students as it is in this department, and I think at the moment is going on the correct direction. But I think the construction sector has much demand and much specific requirement. So if you can, as electronic, if you have construction, also have another division or another system, I think it's much better to that who are going to the construction field, that the students have much guidance for that their construction related material testing and like that. And other thing is in the training you will find is most of them are very well, and they have good collaborate with the organization, and we very happy about that because they are also, some of them are also coming as our recruit as a employee even also. So thank you for this kind of forum also. Then I just think about the construction field have much wider spectrum for the material engineering, because at the moment actually the construction field civil engineer about materials have sometimes have lack of information about how the testing like that information that can be avoided by using the material student to that place, because they have much aware about how the material wise how do we need to fulfill the construction requirement. So that my just comment. Thank you very much.
Yeah, thank you very much for the comment. Of course, construction industry, we consider it as a source of employment. Actually, one of the highest source of employment for our graduates at the moment. And of course, based on that, of course, recently we have done some curriculum changes also, introducing more construction related modules. But still we haven't thought of going for a, specialized area on construction industry, but maybe we have to look at the future. If there's a potential, maybe, of course, that is a good suggestion. Right, thank you very much for your comments. Any other comments from the industry? Yes. Yeah.
Yeah, good afternoon. Thank you very much giving opportunity for us to share real industry and academia, how we can have the better strength. So I represent from the polymer industry. Basically, I think last 15 years we are taking minimum 2 of your material students, and we do structured training, like given 2 weeks minimum, because we are having plastic, rubber design, even the lean management and all this. So we do the 2 weeks induction training, introduction, then we ask them to select their own projects. Plus then they have to present at least 2 times per month their performance. But what I feel, as one gentleman mentioned, see today's the world is changing. More virtual technologies come in. I'm glad that one of these computer-aided simulation is used for the project. Maybe some of you not aware, because now we, through the government, from the private sector, we launched last year August the National Finite Element and Simulation Center, which is one of first project I have seen, because we are founder members of that association, we are voluntarily working. But my point here is, even I see that when you are getting you are especially the material engineers, we are now into the atomic level simulation. The world is that way. I don't know up to which extent your syllabus is updated to that technology. Plus, the design area, because I try to get some more people, especially we have our own design center, which is with all software we are using, and we are doing our service to the globally. With that, we are finding some difficulties to get this material engineers, because when you come to simulation, it is not just mechanical engineering, because you have to start with, as very correctly mentioned, upon the concept design. So what I suggest, so how you can review your today's the syllabus, maybe to meet the the tomorrow's requirement. So with that, I think the commitment and all the supervision from your university and the testing practice, what we are doing with the university, have very good relationship. That what basically we want to have more, because today's business innovation model is coming through the industry, academia, and the government. So with that, I think if you can more focus on that area, it will be benefit for as far as the students are concerned and the prosperity of the country. Thank you very much.
You are from Elastomeric, no? Yes. Thank you very much for your comments. Of course, your comments are well taken. We have moved into this finite element analysis plus all other materials modeling aspects. Of course, it's been discussed in the department at present to introduce a material modeling module, basically targeting maybe semester 8 or semester 7, like final year students, to enhance their modeling capability. We have identified that requirement. Of course, there's a requirement from the industry also. So we are moving into that direction. You can see the projects, of course. You can see the projects. People have done a lot of simulations. Even Abacus has been used, which has the license of this RRI facility. So of course we are trying to have some collaboration with the RRI facility to get some kind of collaboration, because we don't have the license versions here. So I think only RRI have at present in Sri Lanka, maybe some other private entities. So we are moving into that direction. Thank you very much for your comments on this. Right. Thank you. Any other comments from Albex?
So that I am from Access Engineering.
Right.
I want to say something that is my responsibility from our company. Actually, I want to thank to Material and Science Department. Why, as a QA/QC manager, I work more than 10 engineers who came from your department. And I noted one thing, and we are always interested to take your people. Main one, as a eldest, I can say something that especially that disciplinary students. who are coming out as a graduate, but they are respective to the seniors and the joining the companies. And 5 engineers working with me in waterfront. And waterfront project is the very largest project, and high-rise buildings, more than 40, 45 stories, and the new technologies that steel columns and a lot of new technologies involve that project. And your students work with me, and they are very short time they catch the techniques, and they help to our company to success that project. I want to thank to your department behalf of my company, Access Engineering. And second thing, Dr. Adhikari also know that sometimes as a contractor we are dealing with the consultants. We are facing some problems. We have a difficulty to prove that points to the consultant. Actually, I can remember 2-3 times the department, your department help us to prove some technical matters for the consultant, and they believe that and they admit that our work because of your explanations. And other ways, we are always coming here to do material testings, especially steel. And normally I like to tell very frankly that our consultant service, they are foreigner or the local team, they are totally believing and trusting, and they like we are handing over the samples to University of Moratuwa for testing purpose. And that work also very quick service, and exact results we are getting from your department and your students. And that is the main one you want to know. And I can say they are very intelligent and respective mind people. And I noted they can find out anything in the modern industry. Thank you for department.
Thank you. Thank you very much from the Access Engineering. Of course, we have a lot of collaboration with Access Engineering. Of course, even for this event, they have given some sponsorship. Okay, thank you very much for your comments. Of course, that comment, of course, opened the door for the other things also that we have mentioned here, like consultancy services and testing services that we offer in the department. Of course, those two are one of our, I would say, number one strength, like with the industry interaction. Of course, we do a lot of consultant services as well as testing services. In some sectors, of course, so we are the only one, basically a reliable type testing facility in Sri Lanka. So as mentioned by the gentleman from the Access Engineering, of course, most of the consultants and most of the companies trust our results and respect our results in the consultancy and testing services. Okay, any other comments under this title, especially under industrial training?
I represent Alumex, and thank you very much, the team here, for giving us this opportunity to discuss and create this platform for us to get our comments from industry. I have a general comment regarding the communication between you and us. Specifically, there are a number of opportunities with us even right now at Alumex for training opportunities. I tried through HR to get a couple of undergraduates. This is a general comment, not only for material engineering division, but for all other divisions. So I think as an improvement opportunity, if we can create a single contact point here for us to deal with the university when it comes to this division, so that it will be easy for us to get when there are, because number of project and there are number of issues in the industry. So if you can give us, because last time the communication didn't work well, we didn't get undergraduates. There are, even now we have opportunities. So if you can give us the better way of information flow and giving these opportunities, I think that is one good opportunity for us to work together. Secondly, on the local development, and now we recently established our R&D division. We didn't have a proper R&D function, and I think there are when we go through these project presentations and the services that the university, this university offers, we have enough opportunity to work together. Because there are areas now we spend a lot of money on these testing. Sometimes we have to send samples to maybe other countries. So these testing services will help us, and even this, I think, hopefully this gives better, even for us, it will be cost effective to do these testings. And if you can send us, related to aluminium, I don't know how the university works on these areas, because I am working with Dr. Indika these days with some other projects in our factory. So if you can give us a brief, like kind of, what are the areas that you can help on these things, specifically for aluminium industry, because we need to understand those. So I think the communication between us and you have to be improved, in my view.
Yes, thank you for the comment. For the first one, a single contact point. But for the training, of course, it's the in the faculty we have a separate division, industrial training division, headed by the director, industrial training. So basically, they are the one who coordinates training of the whole faculty. Actually, the training occurs in done in semester 5. So by that time, of course, they will contact the industries and come up with a list. Or else, if you have any specific training need by a specific field, you can contact directly the department concerned. And for the training is arranged like that. But for the consultancy, we have to contact directly the departments. Of course, we can provide the information for testing. Facilities available for specifically for the metals like aluminium. We have the facilities. So I think that should be better described by the head of the department. You can.
Yeah, regarding consultancy and testing, the main contact point is the head of the department. So if you make a request to the head of the department, I can direct you to the appropriate lecturer or to where the facilities are available, so that you can directly communicate with us and get your work done. So or since you're already in contact with Dr. Indika, I think that is also another way to work with. So if you have built up a research collaboration with one of our staff members, you can always continue your projects through that way as well. And yeah, so basically that is how we can operate.
Any other comments?
I represent CAMSO actually. Last time also we had a student from material department. He worked very well during his training period, and he has started some projects also. We can continue them. With regard to our requirement, especially with regard to the consultancy, Dr. Indika already has started some area. Apart from that, we have requirement with regard to the material characterization, especially incoming material, as well as there is a opportunity for students to study liquid metal processing with regard to the simulation software. There is a facility in our department, so there is a possibility to come there and learn more about liquid processing with regard to metal industry.
Okay, okay, thank you. Now this, the of course, training, of course, we always send trainees to your establishment. And the simulation facility that you mentioned, of course, I think you can better utilize them by, jointly undertaking undergraduate or postgraduate project. You can go to the next slide. So that again opens the next slide is basically research and development activities of the department. So there, of course, we have the undergraduate research activities, postgraduate research activities, industry department, collaborative research and development work, collaborative research with research and academic institution. For the undergraduates, of course, they have to do a project, a research project in starting from semester 6, goes up to semester 8. It's an 8-credit module. Then we have postgraduate students who do taught courses plus a research component, and you have full-time postgraduate research students also. And even at present, we conduct some industry department collaborative research work. So depending on the requirements, of course, we can sign a MOU and then proceed with the research project. And of course, we have another type of collaborative research work with the government institutes, other universities, etc. So if you have any research interest to develop your projects or to solve your any industrial related matters, of course, we can facilitate those things depending on the requirement and depending on the facilities that we have. So any comments or requirements regarding the research and development activities, of course, you can comment.
Yeah, actually, this is related to the earlier slide. Let
Sure.
me give a quick update. Because what I have seen, the students passing out from materials engineering department, they are having good innovative power and kind of adaptation to the industry. Because that's what, as most of the people explained. And just as a comment, because University of Morocco is known to everybody. But then there's a question mark. This is from my side, like whether from the university side we have explored the total potential in the market. What are the places that our undergraduates could go there and train? Because there are a lot of industries like BOI projects, and in the BOI zones, a number of industries and the companies. Like there could be a lot of opportunities, but which is unknown to the university. But I know that many of the industries have that means they have in collaboration with the university. But still, there are some unleashed companies or unreached companies by the university, and most of them are catering to not to the local market but to the international market. That means they are using most of the latest technologies. But I'm not saying that not the local companies, but they are also using the latest technologies. But there could be a lot of opportunities in the market than we see right now. So this is like a comment from my side and the suggestion that if as the university and by using our students or the academic people or lecturers, I think that could be some of the project, a short-term project for the final year students or just pass out students, just to explore the total market potential for the materials engineers. So that means then the horizon would be expand. So thank you.
Yes, thank you. Thank you very much. Your point is well taken. Even now, of course, for the undergraduate projects and even for the postgraduate research, industry collaboration is there. But of course, we want to improve and we want to diversify, as you mentioned, into other areas that, of course, may be unknown companies, etc. Yes, we are looking into that. Thank you very much for your comment. Can you move on to the other slide, please? 1 o'clock. The next slide is the employability of the material science and engineering graduates. Of course, maybe during Mr. Veeragoda's presentation, he mentioned few slides, so maybe he can elaborate on it.
Yeah, so this is, well, the employability of our graduates is our main concern, but so far we actually don't have an employability issue because we have almost 100% employability even before the graduation. However, we know times are going to change and we have plans to increase our intake in near future to 80 students. So in that context, we may have to explore into new areas for our students to operate on. And I think we have already got some comments and suggestions regarding that from the audience already. But if there are any suggestions from you to improve on any of the shortcomings of our graduates, we will be happy to hear and make corrective actions on them.
I guess I just to emphasize that non-destructive testing has.
Yeah.
I can comment on the non-destructive testing. Of course, we have in the material testing laboratory, of course, we have a separate division dedicated for non-destructive testing. At present, of course, we do ultrasonic testing. So that is our strength, ultrasonic testing. We have the expertise and the equipments. But of course, in future, we hope to develop the ultrasonic testing into other techniques also. Yeah, yeah. Yes, vast area. Yes, thank you very much.
I think one comment on this, very clearly identified the I think again on the knowledge and technical skills and the creativity, we don't see any problem of the graduates coming out from the university and this faculty. But in a general perspective, I think the managerial skills, soft skills and communication skills, I think you could have done better in terms of improving there. It comes throughout the experience as well. But I think when it is easy for the industry, if the students or when they just entered as a corporate world, if they have better understanding and better skills on these areas, I think that I see there's a gap in the fresh graduates specifically.
Yeah, actually, this deficiency in the soft skills, especially communication and the managerial skill, we have been observed this even in past DICB meetings. There are a lot of comments, and we have taken a lot of actions also to improve those things, like special things even with outside the curriculum activities we have organized, like mentoring sessions, etc. But still, there are a lot of things to be done. We acknowledge that, and we are doing continuously, try to improve this situation, because you have to understand that we get students from various backgrounds, from all over the country, different districts, of different schools, different backgrounds, etc. And they stay here only for about 4 years. And of course, we have a curriculum of 150 credits. So of course we are doing our best to inculcate these qualities. Thank you very much for your comments. It's well taken.
My question is relevant to the previous slide, R&D and a lot of postgraduate projects. So what I feel, I'm in aluminum industry. So the most abundant material in the world is aluminum, but we couldn't find we very hardly find that the research and developments in Sri Lanka. If you go to the internet, you can see a lot of articles written on the sites regarding the aluminium. But still, I don't think Sri Lanka is still that develop that kind of enthusiasm or the developments or the I think education have gone up to that level, because a lot of engineers coming out from the University of Moroto or other universities, they are prepared to go for the steel or the other kind of materials. But Sri Lanka is booming with the construction industry, and aluminium is a part of the construction. So I think we have to go and seek the new R&D methodologies and R&D developments regarding aluminium.
Yes, actually, if you consider the metallurgical research in Sri Lanka, as in universities, only Moratu, Department of Material Science and Engineering, is the place actually carrying out metallurgical type research. So of course, there are few research on aluminium is going on. I think Dr. Indika is the one who is conducting those research. Of course, steel is, of course, is the kind of most common type of material that we encounter in the construction industry. So that it's a popular material. So that we have a lot of R&D work. It's based on the demand, basically. Personally, I think it's based on the demand. But I know now in Sri Lanka there are several companies, including Alumex and other companies, are involving in aluminium related businesses, and they have a lot of issues with the quality, etc. So that of course we can initiate. If you can collaborate with the university, of course we are ready to initiate that type of research activities to help the industry. Of course, to gain the knowledge for the university also, right? So of course there are formal ways of starting a project. Like if you have an interest, you can come to the university and discuss the problem, so that depending on the quantum of work required, basically we can design the project, a collaborative project, or else we can employ a research student to do the project for MPhil or MSc or PhD. Of course, if you need, we can have a MOU between the company, and of course these non-confidential, those type of requirements also can be fulfilled and proceed with the project. There are projects running like that in the department. Of course, you are welcome. You are welcome to initiate this type of dialogue with the department. Thank you. Since we are running out of time, we will move to the next slide. So this is about the undergraduate, postgraduate programs and our research activities, the way forward. Maybe again, Mr. Verogan will explain that.
Well, as I highlighted in my presentation, our graduate program is actually accredited by the Institute of Engineers Sri Lanka, and the framework of the program is guided by their requirements mainly. So even in the way forward, we'll have to stick to that framework and work through the same procedures. However, One of the things that we have been developing in the department of recent times is the amount of research. So in last few years, we have actually almost doubled or tripled the amount of research publications from the department, and also we have increased by several fold the number of research students who are involving in various study programs. And so that is one of the aspects in material science and engineering that we hope to go forward in the future as well. And also, as I mentioned earlier, with the increase of increase of intake that we might have to do in a few more years, we will be focusing more on the manufacture, the construction area as well for the students' employment, as well as we need to, we need to educate, or we need to enlighten the manufacturing sector as well regarding the possibilities, or regarding the capabilities of the materials engineering graduates. So those who work with the industries that work with us closely know what materials, have an idea about what materials engineering is, but we certainly need to expand our scope and area of action. So but as you being our main customer, so to speak, of you are the employers of our graduates, and I think we have already received some suggestions and comments regarding the way forward as well. But we will be happy to have some of your ideas and comments if possible. And always, I think we need to be in touch with the industry as well. And I think we need a kind of a better or a much closer forum with the industry in order to exchange ideas, because sometimes our input can also help your way forward as well as the other way around. So anyway, I hope we can have some comments on, or comments or thoughts on our way forward.
Right. Thank you very much. Of course, in the way forward, of course, I'd just like to mention that, we have got a government grant for a new building, about 400 million rupees for a new state-of-art 5-story building. It has been approved by the cabinet, and we have all the tenders also. So maybe within another 3 years' time, of course, we can shift to the new building. And so on a condition, of course, they have given the grant. That means we have to increase the intake. So that maybe, so that means once you get the building, of course, we have to increase by 30 numbers. That means altogether our intake will be 80 students per year. So that means, so our future seems to be good. Even the government has recognized that. Okay, I think it's time to wind up the session. So we have almost past 1 o'clock now. The next item is the lunch, so that I don't want to stay between the lunch and the session now. So thank you very much for your comments. Of course, we got several very important comments, especially about the industrial training. Our request is to give industrial training, well-structured training, including mentoring. So if you have any concerns or any issues with the industrial training, directly contact the industrial training division of the yes.
For your information, next industry training module is scheduled to commence from 27th of May. And my email is anandaji@uom.lk and this one is e@uom.lk and you'll welcome. And we can, as you mentioned, I think better to have a direct dialogue. I think that's the best thing. We are really welcome. Because we also go to HR and sometimes the profession, I think that is very convenient. Yes.
And also, we appreciate your comments regarding the research and development and the way forward. So thank you very much. Your points are well taken. And finally, I thank you all, those who have given us comments. If you have any other comments, of course, we can discuss during the rest of the day and during the lunch and the tea sessions. So your comments are welcome. Thank you. Thank you very much for your attention. Thank you.
Thank you, ladies and gentlemen. This brings to an end of the first half of the proceedings. The symposium will now be adjourned for lunch and will resume here in an hour. You will now be ushered to the staff lodge. Thank you.